In this video, we're going to be using the weather station kit. Flash the ESP8266 and replace it with new firmware. We're going to update our Arduino IDE. We're going to also update and or install all the new libraries. So this is going to be a fresh start to just get that ESP8266 working whilst using a Mac. In order to flash the firmware, we're going to need an application that writes to the ESP8266, and we're also going to need the file that we're going to use as the firmware. So the first thing to do is to go to NodeMCU-build.com, and here you can actually have your own firmware built. The default settings are absolutely fine, so I just left it as those, and what you do is you sign up. Then it will build and it will email you 2 files. Once you get the email after a few minutes, you will have the float and the integer variation. I've chosen to download the float. Once you've downloaded that file, put it somewhere safe, like on your desktop. And the next thing we're going to do is going to go and get the flashing tool. So for that, we're going to go to GitHub. We're going to look at the PY flasher. Which is just the application that is going to push that firmware to the ESP8266. If we go to releases, we're looking for the latest release for your Mac. I don't have an M1, but I do have the Intel, and the Intel works. If you have the M1, you can try it. Otherwise, you might need to look for an alternative flashing application. So go ahead and download that. Once that's downloaded, go ahead and put that somewhere safe, then install it. Once it's installed, you might need to two-finger click and then open to launch the application, as you'll need administrator rights on the Mac. Now that you have everything installed, you'll need to plug your ESP8266 into the Mac via the USB. Run the flashing application. Go to serial port option at the top of the window and select the USB port that you're using. Then if you click browse on the firmware, you just need to locate that firmware file, then keeping all the defaults, flash your ESP8266. Now it does take a little bit longer than this, I've just sped that part up. Once it's done, you should get this message that it's been flashed successfully and you're ready to move on to the next stage. So now we run the Arduino IDE. As you can see, I'm running 2.2.1 at the moment. It's asking me to download the latest version, which I will do. So as you can see, I've opened up the Arduino IDE and my version is now 2.3.0. So you can see that I've updated it. The next part is to start installing the actual board, the 8266. So for that, we're going to have to go to File, Settings, and then we're going to input the following address into the additional boards manager URL field. So the next stage here is selecting the board, and even though it's grayed out, we're going to click it. We're also going to click the USB port. Because it's grayed out, it means it hasn't been installed, so you should get a prompt to ask you to install it, so say yes to that. Now on the left-hand side of the screen, in Library Manager, you're going to add the following libraries. The SSD from Adafruit 1306, so go ahead and install the latest version of that one, and install everything. So the next library we're going to install is the I2C detect. And this program will just tell us what the address is of the screen that we've connected to the ESP8266. Next library is ESP8266 Weather Station. And we're looking for the library from ThingPulse. And again, if you can just install all the dependencies on that one as well. The following library actually comes with the weather kit itself, but I think it's an outdated version. So this is ESP8266, and then you need to press -OLED and you should get the ESP266 and ESP32 OLED driver. Now that we've got all the libraries we need, it's time to go to Files, Examples, go all the way down to the bottom and select I2C Detect and then I2C Detect. And what this program is going to do is it's going to find the address of the screen that we've plugged in. So before uploading this sketch, you'll need to hook up the screen to the ESP8266 using the following connections. You want your 3 volt from ESP to go to your VCC. You'll need your ground to go to G. Your D1 from your ESP needs to go to SCL on the screen, and your D2 needs to go to SDA on your screen. And that configuration matters because the library wire.h has already stipulated those connections. Once I upload that code now, it's also worth noticing that SDA and SCL on the image are different to SDA and SCL on the screen itself, and a lot of screens do have it in different positions. Once your sketch is uploaded to the ESP, it's time to go to Tools and open up your serial monitor, and we're looking for the disruption in the dashes. And if you see here, I've got the 3C. So that's telling me that what my I2C address is, and I'm going to remember that. If you've run the sketch and you're looking at serial monitor and you're getting the dashes but no letters or numbers, then you may have got your D1 and D2 the wrong way round. Just a quick one on the serial monitor. I know that a lot of people have said, oh, it's just chucking out strange characters. If that happens, just check your baud rate. It's supposed to be 9600 for the serial monitor. So as you can see, I'm just going back into 9600 and those symbols have changed. Now that we know the I2C address and we also know that the ESP is talking to our Mac and is talking to the screen, we're going to go to File, Examples, and we're going to load up the Adafruit SSD 1306 SSD 1306 128x64 I2C. Now this is loaded. We need to go down and we're going to have a look at the reset, and we're just going to make sure that that is -1, and that's because we don't have a separate reset button on the screen. We're also going to change the I2C address to make sure that it relates to the address that we have, and in my case it was 3C, so this will be 0x3C. So I'm happy that the ESP is talking to the Mac, so what I'll do is go to Tools, and then I'm going to increase the upload speed higher than what it is, so I'll choose the 460, and that just means a little bit faster uploading the sketch to the ESP8266. Now it's obviously going to take a lot longer than it's taking me, and I've just sped up the video. So now that the sketch is uploaded, I'm going to hit the reset pin, and you should see something like this. The graphics aren't rolling, it's just the frequency of the camera on the phone. So happy that we've got everything working and we know the screen works. We're going to go into Examples again. We're going to go ESP8266 and we're going to load up Weather Station Demo. Once this is loaded, we're going to scroll through. We're going to change the time zone to whatever time zone you're in. I'm personally in Singapore, so that is an 8, but there's summertime, so I actually left the summertime in and then changed it to 7. Probably not the best idea. The next thing I'm going to do is just check my I2C display address, which is correct, and then I'm going to change the SDA pin and the SDC pin, which is the SCL pin, to that exactly what I had before, which was D2 and D1. Now because this is a weather station, it's got to take the weather from somewhere, so we need to go to openweathermap.org. We will create an account. We will then get an API key that will be personal just for us. We will search for a country or an area that you wish to get the weather for, and you'll need to make a note of both the API key and also the channel number for that country you want the weather for. Now that channel number is in the URL, so you can see here 188.0252. Take the API key, go back to your sketch and just replace the XXX with the API. Then if you look a little bit further down where you've got the location ID, if you go and copy that channel from the URL and then just paste that in place. Scroll down a little further, you want to change your language unless you speak German. So I speak English, so I change that to EN. And lastly, just put your Wi-Fi SSID and the password to get you into the network, making sure that you are 2.4, not 5 gigahertz. And so for the final upload for this video, we're pushing this sketch into the ESP8266, and I restart it, just pressing the RST, although I think it does it automatically, and you can see that it is picking up the time and it's picking up the temperature and the forecast for Singapore.